Hey guys, welcome back to my last video of the series Bash Shell Scripting Tutorial for Beginners. Now let's get started. Today we'll look at signals and the trap command. So what does a signal do? A signal indicates that a user has asked the program to do something that is not in the usual flow of control. For example, when we press Ctrl plus C while running a script. So what does it do? It interrupts the normal flow of control. Linux uses these signals to communicate with the processes running on the system. So a signal can be used to stop, start, or kill a process. If you want to see the full list of signals on your system, then you can type in the command trap-l. So in Linux you have 64 signals. You can either type the command trap-l or you can also use kill-l. So these signals can be referenced using the corresponding numeric values. Now let's look at some of the most commonly used signals. The first one is SIGUP. This can be referenced using the numeric value 1, as you can see here. So this signal is used to hang up the process. Say if you're connecting to a SSH server and the server has disconnected you or you accidentally log out. Generally two things can happen. Either the program ends properly when you log out, or if the connection is dropped, it will try to reconnect you back to the server. The next signal is SIGINT. This can be referenced to the numeric value 2. This is the interrupt signal, also called as the death of process. This is normally activated when you hit the Ctrl and C, as we mentioned before. When a script is running, you interrupt in between. So SIGINT is the interrupt signal. Now our next signal is SIGQUIT. It is referenced by the numeric value 3. When the user presses Ctrl D to force a process to stop, or when you use the kill command to stop a process. Now our next signal is SIGFPE. It is referenced by the numeric value 8. This signal is used when the user tries to perform an illegal math operation, for example, a division by 0. And the last signal is SIGKILL. This is referenced by the numeric value 9, and this is used to kill a process. Now let's run this. So when we press Ctrl plus C, the SIGINT signal will be activated and the program terminates. Now instead of interrupting the process, now let's kill the process. To kill the process, we'll need the process ID. So let's print the process ID. If you type $, it'll print the process ID. Now let's save and run this again. So we have a process ID here. Now let's open another terminal. Now to kill a process, you can type in kill. And the numeric reference, if you remember, SIGKILL had the numeric reference of 9. We type in 9 and the process ID. So here the process ID is 5039. So as you can see, the process has been killed here. So why do we need the trap command? The trap commands can be used to ignore these signals. Now let's see an example. So first you have to write down the keyword trap, and in the double quotes you can write what to happen when the signal is triggered. So in this case, if you notice what happens is, if we try to do a keyboard interrupt, which is Control C, then it'll print I won't stop. So we won't be able to use the Control C to exit out. Now let's try to run this. Okay, now let's press Control plus C. So as you can see, it prints I won't stop. So now let's kill the process. So this is how you can use the trap command. Now let's use sig kill instead of sigint. Now let's save and run this. Now let's try to kill the process. So 5203. Since we mentioned the kill signal in the trap command, it was supposed to ignore and the process was not supposed to be killed, but still it got killed. Why is this? This is because the trap command has two exceptions, which is for the signal sig kill and for sig stop. So the trap command will not be able to stop these two signals. Another reason to use the trap command is to remove unwanted files. Let's see with an example. Now let's save the output of the command ls-l into a file called output. Now let's set this trap command to delete a file if our script is interrupted. Let's set the file variable. So since we are running it on desktop, it will be created on desktop. So let's set the location. File output. Now let's save and run this. Now let's open another terminal. So as you can see, our file has been created. Now let's interrupt this. Now let's check again. So as you can see, the output file was deleted since we activated the second signal. Now let's see this again. Let's not interrupt it this time. As you can see, the file has been again created. Now let's read the contents of the file. So the file has been successfully created with the output of the command ls-l. So I hope you guys have learned quite a lot from this tutorial series. So thank you for watching my video and stay tuned for more.